All right, Lesson 8. This is where our API finally grows up. Up through Lesson 7, we've been faking persistence with in-memory dicts, and the moment the process dies, so does our data. SQLModel fixes that, and it does it with a clever trick. One class definition that's simultaneously a database table and a Pydantic schema. No double bookkeeping, fully type safe, written by FastAPI's own author. So here's the roadmap. 4 mental models that together form the persistence layer. First, defining a SQLModel table, that one-class trick where the same fields validate incoming JSON and map to database columns. Then engine and session basics, the standard SQLAlchemy pattern wired up the FastAPI way with depends. Third, modern select queries that MyPy can actually validate at write time. And finally, relationships with eager loading, which is exactly the shape the Lesson 12 capstone cart will rely on. Let's start with the pattern itself. Itembase holds the shared fields, name and price, as a plain Pydantic model, no table flag. Item inherits from it and adds table true, plus the ID primary key and a created@at timestamp. That's your actual database row. Then item create and item read inherit the same base for API input and output. Same validators, defined once, used 4 ways. This is the end of maintaining parallel Pydantic and SQLAlchemy models. With the models settled, we need somewhere for them to live. The engine is your connection pool to Postgres, one instance created once at startup, shared across the whole app. The session is different. It's a transaction scope, one per request, opened and closed by the same depends with yield pattern from Lesson 7. Wrap that in a session dep type alias, and your handler signatures stay clean. And create all is fine for dev. Reach for Alembic the moment you ship. With the session in hand, CRUD becomes refreshingly boring, in the best way. Create is just add, commit, refresh, and that refresh is what hands you back the auto-generated ID and created at. For list, you build a select statement, optionally chain where for filtering, and exec it. Notice item.name.contains is a real Python attribute. MyPy catches typos at write time, and there's 0 string interpolation, so SQL injection just isn't on the table. Now for relationships, the shape that's been hiding in our cart since Lesson 1. 2 sides describe one link. The child carries the foreign key with field foreign key, order.id, and relationship on each side wires up the Python attribute. Back populates is what keeps them in sync. So loading an order gives you order, items as a real list of line item objects, no manual joins, no second source of truth. But that convenience has a sharp edge. The moment you loop over orders and touch items, lazy loading fires 1 query per order, fetch 100 orders, you've just hit the database 101 times. The fix is 1 line. Pass selectinload order.items into your selects options, and SQLAlchemy batches everything into 2 queries total. On 1,000 line items, that's roughly a 500x speedup, easily the highest leverage ORM change you'll ever make. That selectinload fix is the first of 6 reflexes worth burning into muscle memory. Always reach for session.exec over session.execute, same statement, but you skip the .scalars, unwrap. After every commit, call session.refresh on the object so the database-generated ID and timestamps actually exist on the Python side before you return it. In production, swap create all for Alembic migrations, tune pool size plus max overflow against your Postgres connection ceiling, and put index true on every column you filter or sort by. 6 small habits, and they're the difference between an API that survives 10 users and one that scales to 100,000. Here's the whole lesson on one screen, that 12 patterns you'll reach for daily. Top row defines the schema. Table, true, turns a class into a real DB table, primary key marks the ID, foreign key wires relations. Middle row is the runtime. Index your hot columns, build the engine once, open a session per request. Bottom row is the work itself. Add and commit to save, refresh to pull defaults back, get for primary key lookups, exec with select for queries, relationship for navigation, and selectinload to kill n+1. Screenshot this one. Now the war stories. These 5 mistakes all work fine on your laptop and all blow up around 50 concurrent users. Number 1, n+1 from lazy loading. Fix it with selectinload. 2, forgetting refresh after commit so your client gets a null ID. 3, create all in production wiping your tables on a schema change. Use Alembic instead. 4, sharing a session across requests, which leaks state and deadlocks. And 5, a connection pool sized larger than Postgres can serve. Recognize these before they recognize you. Time to put hands on keys. 3 exercises building on each other. First, take the L05 CRUD and rewrite it with SQLModel and SQLite. Same handlers, same status codes, but restart the server and your data is still there. Second, add the order and line item relationship and create both in a single transaction. That's the cart shape you'll ship in L12. And third, deliberately trigger n+1. Watch echo true print 51 queries, then drop in selectinload and watch it collapse to 2. And that's lesson 08. Your data persists. SQLModel gives you one class for the table, and the schema, the engine and session manage connections, select handles queries, and selectinload kills the n+1. Next up, lesson 09, where we lock the front door with JWT and OAuth2, token-based auth, bearer headers, refresh flows, and proper password hashing. See you there.